Hello. It's Wednesday. It's Fake Friday for me. I hope everyone had. Oh, my hair's rowdy. Hope everyone had a good day. I had a day writing a lot of slides. Let me pull up chat and such. Okay, cool. Yeah. I don't know how long ago. I feel like I say that every single time, but I still got a lot more slides to write, and I'm running out of time. So, I want to go over what I have. I already asked the folks in chat for some feedback and got some good vibes back, so that's good. But yeah, I'm giving my talk this weekend at Rust, China. I can show my, let me pull down my current page, export. Pull up my, no, that's not even my, that's not the slide I wanted to export. How do I go? Export as PNG, custom ranges, page 1, export. Just give me the title slide. Title slide. Here we go. This is my title slide. So I'm giving my talk at Rust, China soon, this Saturday, the 13th. So I'm working on my slides. You can tell I have extremely a brand for using departure mono, and this is done in types. They gave us a lovely template in Google Slides, and I went, okay, that's lovely, and then turned it into a typed template. So, because I am who I am. But yeah, I have my outline now. Nick's gang, yeah, exactly. So this is spoilers if you're gonna wait to watch the talk or if you're gonna see it live. This is extremely spoilers. But yeah, I mean, I usually break my presentations up in like 5-minute chunks because it helps me. It's like the 3-paragraph or the 5-paragraph essay from, I don't know if anyone else had that in school, if that's a thing that they still do at schools, but that's how I was taught to write essays at school. But it breaks up the 25-minute block in a fairly reasonable way, and yeah, it helps me with pacing. And a lot of times I'll fudge this, like it'll start 5, 5, 5, 5, 5, and then I'll realize like, this needs 2 and this needs 7, and but it usually helps partition things for me. So this is usually how I write slides, is I vomit a bunch of ideas out on like note paper and stuff like that, and then figure out what I'm going to talk about, and then I give myself 5-minute chunks, and then I usually give myself like 1 point per minute, because I can generally talk about one coherent thing per minute. Hey Dion, hey Aria, hey Alexandra. Good to see you all here. But yeah, so this is usually what I've got as my big chunks. So intro and history, the big idea of like Ergot and message passing and networking. Dion said 1 minute per slide. Yeah, I take a different approach to slides. This will probably turn into like, what is this, 25 minutes? I mean, some of my slide decks have been like 120 minute or 120 slides for 30 minutes, but I also write slides that are like, instead of putting like a slide with bullet points on it, I'll make 8 slides. I like having 1 sentence on the screen, or not even a full sentence on the screen at a time. So each of these will probably turn into 2 or 3 slides, but yeah, it's one coherent. Other people write slides like that where you have more than 1 sentence on them, but I tend to have like very succinct slides, kind of as a subtitle of what I'm working on. But yeah, so intro and history, big idea of message passing and networking and Ergot in general. 5 minutes on how Rust and async basically make Ergot possible. So like, what are all the things that Rust does well that kind of sets Ergot up for success on, like all the stuff with async and the type system and things like that make it reasonable to write protocols like this. And then sort of turning around and going, what kind of systems does Ergot make possible? So like, what kind of things does Ergot let you do that would be harder to do without it, basically. And then sort of the conclusion, because I don't really have a conclusion because Ergot's not done, and it's certainly not at the point where I'm like, you should all start using it. So the conclusion's sort of like coming soon, what Ergot needs, and then future dreams. So kind of building up to the like, hey, these are the things that I want to be possible, and what I think the next steps are going to be. And spoiler, it's mostly more people using it. But and then there's a 5-minute Q&A, so we'll see how that goes. But I mean, history is going to be mostly like me, and then sort of like where embedded Rust has been since like 2018. Hello, is this for Eurorust? This is for Rust China. Actually, I will be at Eurorust, but I'm not giving a talk at Eurorust. I'm doing 2 podcast episodes at Eurorust, which might hit some of this, but this is specifically for Rust China in Hangzhou, September 13th. So then basically some history of like, hey, where did embedded Rust come from? I'm not going to get super deep into this because it is a Rust conference, and Rust has been around for long enough, and embedded Rust has been around for long enough that I don't super feel the need to explain the history. So I'm just basically going to be like, yep, embedded Rust is a thing. Lots of people are doing it. I've been working on device communication, so it's like starting with Postcard. Basically, there's a page in the book that it's like Postcard is a protocol. Postcard is a message format. Postcard RPC is a protocol, but we hit some limitations of this. Protocol isn't actually all we need. We need a whole network of devices, and so that kind of gets into, okay, we have the idea behind Ergot, and then basically going, hey, if we need networking and socket communication and stuff like that, these are old problems. Like, computers have been doing, or we've been doing this with computers since like the early 90s. Networking isn't a particularly revolutionary idea, but the challenge that a lot of people say is like, well, embedded systems are too small. It's hard to have that layer of abstraction and things like that. It's, we can't justify the overhead. We need to do binary shenanigans for everything that we do. And then kind of the punchline is, actually, no, I think we can do it now. And I think Ergot is kind of a reasonable way to do it. And then getting into the picture of like, hey, I want people to be able to have type safe sockets where you can communicate based on types without having to like do all the plumbing of wrangling data and things like that, and also be able to have addressing and routing so that when you plug a bunch of computers into each other, you don't need to necessarily think about how they're talking to each other. They just start talking to each other, much like desktop systems do when you get them networking and stuff like that. Hi there, Rob. And then, like I said, diving into what Rust and async makes Ergot possible. So, like, leaning super hard on embedded, especially for message passing and things, or, being responsive to messages and things like that. And then getting into, hey, async is already about waiting for events and things like that. It's waiting for an event to happen, and message passing is just coupling data with events. So an event arrived with data, more or less. And so message passing and async go together super, super well. And then how stuff like traits make it really reasonable to do this. So people don't need to necessarily worry about how all of the serialization happens or how it works over different formats and things like that. If they just give me a type and say, hey, I can serialize this, cool, they can participate. And then the same for interfaces. Like, we don't necessarily need to reinvent the wheel every time we go, like, okay, it works over a serial port. Okay, it works over I2C. Okay, it works over BLE. We can just say, hey, here's the interface for an interface. And once you have that working, you don't have to worry about the rest of the network stack. You don't have to rebuild a version of it for everything. And then one of the cooler things about Crates.io is once you can publish your message types and things like that on Crates.io, it means that when someone wants to talk to your device, it doesn't mean reading through a data sheet and coming up with a binary protocol format for it. It means you just download their types crate. Like, you just have all of their message types and their endpoints and things like that defined in a crate, and if you include it on your desktop program, now your desktop program can talk to your embedded system, and they don't generally get out of sync with each other because they're versioned the same way that we version other libraries and stuff like that. Then getting into the fact, this is my admission that Ergot is full of unsafe code, and that I get to use the type system and stuff for building safe outer abstractions for it, and then I get to use things like Miri to make sure that my unsafe code actually works the way it's supposed to and things like that. And then really harping on the fact that by the time that we have async await, we have a scheduler, and by the time that we have Rust and a package manager and we can write portable code, we don't need an operating system to make all of these things possible. And this is kind of going back to this one of like, yeah, this is possible, but it's because the operating system gave you networking and sockets and things like that. And the big sort of magic here is that we can do everything bare metal and like in user space, basically. So we can optimize the hell out of everything, because you're essentially building like a custom network stack for your current setup, which is how we get down to stupendously small devices and stuff like that. And then I kind of want to get into like how I use Ergot and how I want people to use Ergot, and basically like, hey, you can structure your app around, or like your firmware app around message passing, and it seems like an expensive choice, but actually it's just channels basically, and especially it's flexible channels that give you the ability to like communicate either locally or remotely and things like that, but really sort of start building async tasks the same way that you do on the desktop, where you go, well, it's just a server and it's going to accept sockets and it's going to make responses and things like that. Then the plan also is to sort of like, I have a diagram here, but it's roughly the plan. I don't know if this is going to be visible, but the plan is to draw like a little box where I've got like main logic and then maybe like a button input and then a motor controller and then some sensors or something like that, and show that when you have those kind of independent pieces, that if all of your communication with your main logic to the rest of the system is going through messages, you could just yank that part of your code out and run that on your desktop, and it doesn't know that it's talking to a real motor or not. You can write simulators for it like stupidly easy, because you're just writing something that sends and receives messages, and you've already defined the interfaces, so it makes it really easy to just extract a chunk of code and run it on your desktop and decouple it, basically. And then sort of the opposite, which I do a bunch for projects, where you write all the drivers, and you write the drivers to be dumb as hell, and until you actually have your business logic working and stuff like that, you run your business logic on the desktop talking to these services that are running on the device, because you might have some like, you know, very latency sensitive motor control stuff going on the device itself. But if your desktop can talk to it every 10 milliseconds to set a speed or read a sensor value or something like that, then you actually don't really care about the latency for a lot of this. And this is super, super useful for board bring up and testing. It makes it very easy to just throw a script at a device and basically extract the brain from the device and still drive the rest of the system, which is like, this is something I did with Post Station, and I do it a ton in Ergot and things like that. And if you've ever seen me talk about like a Pretty Hal machine before, Pretty Hal machine is like this, but using Rust traits. So you can write a driver, for example. So if you write your low-level I2C server on the device, you could prototype your I2C driver on the desktop and stuff like that. And this is another one of those like using networking terms of scaling horizontally, because a lot of times you end up needing to use a specific processor because it has some peripheral or something you need, but then you run out of CPU, you run out of flash space, you run out of RAM and things like that. And sometimes that means buying an even bigger microcontroller, but sometimes there just isn't one, or it's not cost reasonable to do that. So being able to go, okay, well, what if I had one microcontroller for running the display, one for the keyboard, and one for the Wi-Fi chip, and then I have one main MCU running the show? And that sounds, for some people, that sounds really horrific, because now you have 4 firmwares to deal with. But if you can get all of them talking to each other fairly well, it can be a fairly pleasant way of doing things. And then bridging with other tech of going, hey, you know, all of this is this super compact binary format where they're talking to each other and it's all in Rust. But if you need to talk to a Node.js process or a Python script, or I have a lot of clients in the past who have used like C# for hardware test setups and things like that. Basically running a server on the desktop or the PC or whatever that speaks Ergot on one side and JSON or REST or whatever on the other side, or just packaging it as a dynamic library or whatever, is not tremendously difficult. So it's something that you definitely can do, and I have definitely done, not with Ergot, but with like Postcard RPC in the past. And then the stuff that doesn't exist yet, and so I'll try not to lean too hard on this in these sections of like, I'll try and separate reality of today versus, what I want to be able to do. And that's the stuff that I've been working on recently with multi-hop routing so that we can have, multiple microcontrollers talk to each other. Dynamic networks, I don't have a better name for this, but this is like, hey, I want these two microcontrollers to talk to each other, and sometimes one of them's plugged into a PC and sometimes it's not, and they have to keep talking to each other regardless. But if you do plug in with a PC, then the PC can talk to them, and so like it automatically enumerates those kind of things. I've started chatting about that recently. And then the biggest need is just going to be, hey, I want people to use it. I want people to play around with it. I want people to try it out. I want people to give me feedback on it and stuff like that. Mention that, hey, in the future, it'd be cool to use more protocols like BLE or things like that. And then maybe even just name drop something like Matter or TCP. Like, hey, if we get to a point where TCP, or excuse me, like Ethernet or whatever gets cheap enough and small enough, or if Matter gets cheap enough or ubiquitous enough that we want to be able to do this, my goal is still that Ergot's lightweight enough that you can still use it as an application layer, or, it piggybacks very well on other networks like we do with TCP for a lot of our testing and things like that. So it ends up not adding a lot, and it means that until that day where that stuff is cheap and ubiquitous and possible and everyone's using it, which, I don't know. I've never known embedded people to be great at standardizing, if that makes sense. That Ergot is still useful until then, and that sort of my priority for Ergot is to validate useful before I try and stabilize it or set up a standard for it and things like that, because I think that'll happen, but I think that'll happen when we hit a certain level of, hey, people are using it because it's really useful, and then once we do, then we can kind of, solidify it so that we can have fewer portability problems. But the goal is useful before we standardize it, because otherwise it's just like a design by committee trying to imagine the future kind of thing. So kind of really driving home that it's still a fairly unstable protocol and tool and things like that. But yeah, this is I don't know how long that took me. That took me maybe like 10 minutes to go over this, but I know I didn't cover a lot of the detail. But the slides are going. The slides are sliding. And I think this is roughly, I tend to make a lot of edits, and this is one of those things where I'll make the first version of the slides, and then I'll try and run through it, time myself, see what works well, what doesn't, or just like when you run through it, you go, there's no good segue from here to here, so I need to either reorganize stuff or throw stuff away just because it doesn't flow well and things like that. So I think there'll still be some surprises where the talk that I give will rarely do my original outlines match my final talks at all. But like 95%, it probably will. We'll see what makes it through the editing room floor, but I'll probably be quietly sitting on my laptop talking to myself a couple times with a stopwatch and figuring out. The other nice thing about breaking these up into time chunks like this is you can run one section a couple times to get the pacing for it right, or you run it and you realize that it consistently takes you 5 or 6 minutes, or 6 or 7 minutes, and so you adjust this, and then you figure out which ones get cut to make that, if it's things like that. So, yeah, I think this covers as much as I can reasonably cover. I don't think I'm going to go too deep into like the technical guts of how Ergot is implemented, because I could spend 30 minutes on that, and I don't think that's what Ergot needs right now. I think getting people who might be excited about it and to come try it out, if I'm hoping they don't need to know how the guts work, hopefully. So maybe another time, maybe that's what I'll talk about at Your Rust, is some like very specific technical piece of Ergot. But I think this is going to be much more of a pitch piece for the vision than a deeply technical topic. But I think it's going to hit on a lot of technical things, but it's also not an exclusively embedded conference. So I think getting too deep into like how the unsafe stuff works under the hood or how the embedded aspects of it work is probably. Plus, there's going to be like a language barrier there where I think there's going to be a lot of English speakers, but I think there's going to be a lot of not native English speakers, and trying to cover anything in great detail means that I'm going to go too fast. So I think I need to pace myself. So we'll see. I think this is going to be recorded. I expect these talks to be public. If it doesn't get published, then I'll just do another run on stream or something like that. But I'll save the actual slides and talk for the event, and then hopefully they get it turned around pretty quickly. But yeah, that's what I worked on. I don't think I probably won't touch the code for a while. Like I said, in the next week, I might be messing around with it a little bit, but I'm probably not going to be actively working on it the next week. And then once I get back, I'm kind of kicking off some work, so I expect to slow down a bit on this. We'll figure out, when I get back, I'll figure out what the chat or what the stream schedule will be or won't be. But I think I'll probably still stream like maybe once a week as long as I have something to talk about. But maybe it'll turn into like a once a week stream on Wednesdays, maybe. Mondays or Wednesdays would probably be good. But yeah, if you're watching the stream, thank you very much for watching the stream. Definitely come hang out in the Matrix chat if you want. I'll probably put in my last call for questions now, because I gotta go eat dinner and then finish writing my slides before I get on a plane. And do a whole other to-do list of stuff. But yeah, I'm pumped about this. I'm pretty pumped. This is interesting because I actually kind of fenced off the 5 weeks to work on Ergot, and we're kind of at the end of that 5 weeks now, and I'm pretty happy with where Ergot turned out. Like, I feel like there's been a couple of cool new features, but I think a lot of it has been getting other people excited. I'm excited that we have like 8 other contributors to the project now. We've got a bunch of people talking in chat, people showing up to streams, and a lot of stuff has gone from being like, well, it kind of worked once, to, hey, I'm pretty confident this is the shape that it should be. Like, there's always more verification to do, but I'm pretty happy with the architectural shape of it and the implementation of it. And there's still some questions that I need to figure out, like multi-hop routing. Borrowed sockets are still a mess. But yeah, I think we'll get there. Yeah, Alexandra likes being Ergot's Nyx Goblin. Hell yeah. I'm glad we have some Nyx flakes and stuff like that in there. I have no idea what any of those files do, but I'm glad that you have them there, and I'm glad that they work. Rob, thanks for the kind wishes. Yeah, I definitely hope the travel goes smooth. I've traveled a lot before, so I'm not too worried about it. I'm pretty happy with travel. It's just this one's a long one. This is like 18 hours or something like that. So it's one long flight and then one short flight, but we'll see. Yeah. So again, any last calls for questions or any parting words before I travel? And yeah, big plane go burr. Yeah, for sure. Yeah, I'm happy with how the 5 weeks went. It was a good 5 weeks. I'm happy with Ergot. It's not done for sure, but it's in a good place to putz around with for the next maybe the rest of the year. But yeah, we'll see what I'm doing at the end of the year and see if there's that. So definitely, if folks are watching and you have a chance to use this in your projects, that'd be dope. I've started to have people reach out of like, hey, I have this coming up. Would Ergot make sense for it? And now I can more reasonably say, yeah, I think Ergot would work well for that kind of stuff. And it's not quite well, you know, it's research. Now it's usable research at this point. Okay. I'll wait a minute and see if anyone has anything to say. Get more spam requests on Blue Sky. Cool. I don't think there are any more questions, so thanks again, everyone, for watching. It'll be at least a week before I stream, maybe next Friday, but no streams for a while. Come hang out in Matrix. Come say hi. say hi on Blue Sky, send me a message or something like that. But yeah, thanks everyone for watching. I'll wrap up here, and I hope you all have a good week, and I'll see you all in about a week.